Okay, he's sharing his screen. I'm going to go ahead and introduce Dr. David Wolfe. He is Emeritus Professor in the School of Integrated Plant Science at Cornell University. His research and outreach efforts have focused primarily on climate change, adaptation and mitigation strategies, and soil health and water management. In addition to research and extension publications, science communication efforts include writing commentary for the popular press and analysis for policymakers, such as co-authoring the 2008 and 2014 U.S. National Climate Assessment. At the community level, he serves as board chair for the Cayuga Lake Watershed Network, and he is a member of the Lansing Conservation Advisory Council. David will be speaking on transforming New York ag for a changing climate. David, thank you for taking the time to present to our group today, especially as you are easing into your retirement. Thanks, David.
Yeah, hello, everybody. Yeah, I'm slowly easing in. Still a lot of things going on, such as this, and also some community activities that I'm really kind of enjoying, but are taking up a lot of time, but it's fun. Anyway, so I listened to the first two talks, and I think you'll find that mine takes some slightly different angles, builds on them, and provides some different perspectives. So I'm looking forward to going through these with you. And there's some connections here, some links here to New York Soil Health and our climate smart farming program, which I'll be mentioning. And these pictures you see here, we'll get into in the talk. First of all, Elizabeth talked about more, the seasonal differences in temperature change. And I think that's what's really so important. I like that Elizabeth got away from just talking about average temperature. That's something we hear a lot about in the news, but so much it's the seasonal differences in how the climate is changing that are so important to farmers and to really life on the planet and all living things. And this is just another way of talking about the concept that our winters are warming more than the average temperatures are. And this is showing the plant hardiness zone maps, which I often use this when I'm just even talking to gardeners, because many of them are familiar with this. The color coding is based on the last 15 years of NOAA weather station records. So it's just based on thermometers. And this just shows Arbor Day put this together back in 1990, looking at the previous 15 years and what our hardiness zone map looked like in 2006. And you can see no matter where you are in the US, the hardiness zone map is changing. This means that the minimum winter temperatures, that's what the shading refers to, is rising. And so, a farmer can look at this sort of thing and go, or gardeners as well, and go, warmer winters, that might mean I could grow some different crops that I couldn't grow before. Gardeners, the same thing. When I look at that, I also think of all the other living things that will be responding to this, particularly, for example, insects, which are cold-blooded animals. And in fact, we are seeing there's tons of peer-reviewed literature now documenting that insects, both good guys and bad guys, are migrating following these climate envelopes. And many insects, for example, are now persisting in the Northeast in our winters, or doing a better in terms of maintaining their populations in the winter than they could in the past. Same with weeds. So I'll get into some of those things, all very important. So while there's opportunities when you look at this, also reflects kind of the frost-free period. There's a whole negative to what this means for this concept of our winters warming, and it's just changing, putting ecosystems are kind of disassembling in new ways, reassembling that hard to predict. Kind of along with that, what we're seeing back, I guess quite a while ago, 10 years or so, 15 years ago or so, some colleagues of mine and I got together and we dug up some historical records that went back to the 1960s of bloom dates of various perennial plants that are popular in the Northeast, lilacs, apples, and grapes. And we just looked at the historical trend for their first bloom date, spring bloom date, as you look over that trajectory of time. And indeed, we documented that although it doesn't happen every year and there's lots of ups and downs, there was a very statistically significant trend for a 4 to 8 day earlier bloom date. And to me, as a biologist, ecologist, this is what really gets me about climate change, is how we are seeing since the 1960s, the living world responding to this climate change we're seeing. And these perennial plants in particular are really like sensitive weather instruments and are being used by climate scientists now to help corroborate actual meteorological measurement systems as well. And so this is, very important to us. And does also reflect the possibility of, longer frost-free period, earlier blooms, perhaps higher yields of plants, and these sort of opportunities. We've been caught by surprise by a few things, and I've been working on this for about 30 years now. And I never actually imagined when I first got started 30 years ago that with a warming winter world, I'd be called out by fruit crop growers to talk to them about what they're seeing as increased frost damage, increased frequency of frost damage. Both apples and grape growers are having this issue in a warmer world. There's no question that our winters are overall getting warmer. But what we have is much more variable winters. And so this can lead to unusually early false springs, early bloom. I talked about the average going back to the 60s, for example, with apples came to close to 8 days. In 2012, the apples bloomed 4 weeks earlier. And that's because the late winter, we had a long enough warm period that just hormonally got them cranking, and they went into bloom. And of course, went into a long period of jeopardy. Apple growers lost millions of dollars. Many apple growers in this state were often second or third in the US in apple production. It's a big ag product of our state, putting in significant investments in trying to deal with frost damage. And in fact, at Cornell, we just hired in the horticulture department a new fruit physiologist whose one of his major emphases is going to be looking at this issue of these plants responding to false springs and this whole problem. So sometimes what we think, you can look at some aspects of climate change, and particularly in that thing about communication that Elizabeth talked about. People might say, what's wrong with the warmer winter and earlier springs? What a cool thing, it's taken us by surprise. Here, going back to the living world responding. So certainly what we're seeing, it's no surprise at all, is that with warmer winters, longer summers, there's better insect overwinter survival, more generations per season of insects, and northward range expansion. And this has been documented by many peer-reviewed papers. Upper left-hand corner is the flea beetle, a vector for Stewart's wilt in corn. Used to barely, its population was really driven down by our cold winters, and now that's less so. And so this creates not just direct flea beetle damage, but more it as a vector of Stewart's wilt becoming more of a problem. Corn earworm in the lower left-hand corner. Our corn growers have always been plagued with a number of lepidopteran pests, but the corn earworm was one that was more of a problem south of here. Here it didn't usually show up till later in the summer. Here now, our IPM folks have to put out traps to figure out what's happening with corn earworms early in the spring. Kudzu, myself and some other colleagues did some modeling of the spread of kudzu, a notorious, aggressive, invasive weed. Any of you who are from the South know about it. Anyway, it's normally killed back at temperatures less than -4 degrees Fahrenheit. So we simply modeled the expectation, looking at climate model projections back then, that it would be coming into New York, and in fact, it is. So this is, a major challenge for agriculture, and there's a whole aspect of how will farmers respond to this in terms of control of more weeds and insects, and we'll get into that in terms of adaptation strategies a little later in my talk. So I'm not going to go into the details here. This is just a slide, just to point out to you, there are literally thousands of peer-reviewed papers documenting this sort of living world responding, many talking about earlier bloom dates around the Northern Hemisphere, species range shifts, animal phenology also changing, such as insect and bird migration patterns, vector-borne diseases. So all of these things, of course, can affect agriculture directly, and also can affect us in other aspects of our lives besides agriculture and the food we eat. But this is definitely happening. This is as real as what we're seeing happening with the temperature measurements we're taking. This slide was already shown by Elizabeth, I think, showing the for the Northeast. Basically, in a warmer planet, with a warmer planet, more of the Earth's water is in the air as water vapor. And also with warmer air, that holds more water vapor. So basically, when we have an upper atmospheric condensation event that's going to cause rain, there's much more to come down. And the distinctions between different parts of the country really have to do much more with what happens to the movement of this water vapor by things such as jet stream patterns, et cetera. But you can see the Northeast is a real winner here, over a 70% increase in extreme rainfall events. So of climate change impacts we're seeing in the Northeast and in New York in particular, this is the big one. What's that mean? Well, first of all, it can delay spring planting. We've had some farmers who have been seeking, they heard me many years ago and other folks talking to them about, expansion of our frost-free period. They go, well, I'll get longer growing season corn varieties. They tend to yield higher. But sometimes we could have a longer frost-free growing season than we've seen before, but it doesn't mean that the farmers can take advantage of that because they can't get into plant. Well, there's a couple of years ago, they couldn't get into plant till like June. And so they had one of the shortest growing seasons they've ever had, even though it was a longer than normal frost-free period. Of course, flooding can cause direct crop damage due to anoxia and root diseases. And then as was also previously mentioned, I'll get into this a bit more, there's this issue of soil erosion, runoff of sediment and chemicals into waterways. And many motivations for farmers to get a handle on this. I mean, no farmer wants to see their soils running off in gullies into the waterways. It takes dozens of years for any of that to come back. And of course, there's the environmental impact. I live near Cayuga Lake, and I'm on part of the Cayuga Lake Watershed Network board, as was mentioned, I think. This has happened right near my home, just a very recent high rainfall event, one of these extreme rainfall events we've been seeing more frequently here. And this just shows what happens from, and within the watershed, this all pours into Cayuga Lake, sediment and nutrients. This one happened in just very recently, late October. The lake water temperatures, although we had an unusually warm October, they weren't warm enough to really allow the problem of harmful algal blooms to occur. But earlier in July, we had one of those extreme rainfall events, followed by really warm lake temperatures and still lake waters. And we had one of the worst harmful algal blooms we've seen in Cayuga Lake just this past summer. Again, kind of a linkage between runoff. Of course, it's not just coming from farms, it's also coming from stream banks and from asphalt and driveways that run off getting into the lake, bringing in chemicals, nutrients, and sediment. Some things, what do we really do about this? And that's what I want to get into, dig into a little deeper in my talk. So really when it comes to like grape growers, I think I very seldom anymore compared to when I first moved to this region, see a vineyard that doesn't have inter-row ground covers going on for access to the fields, but also to avoid the soil erosion problems. And so that's been something we've really seen take off. But of course, with some of our annual crop growers, we do still see a lot of fallow soils until they're putting in their commercial cash crops, and that's something we have to get away from. I think everybody, in this audience today is very well aware of really animals call it a little mini revolution of what's happening with exploration of fall, winter cover crops and cover crop mixes by growers in New York State. A lot of exciting things happening there with the seed producers as well as the farmers and the ag service providers such as Soil Water Conservation District and our CS people, Cooperative Extension, working with farmers, exploring these things. Those cover crops, of course they can help. They're sucking in CO2 more of the season with having this, and helps increase soil organic matter, which I'll mention later in my talk and has already been mentioned, very important for soil health. But one thing about cover crops is we often talk, when we talk to farmers about soil health and building organic matter, which is a good thing, that can take years to build up your soil organic matter. But with cover crops, you can see the benefit in terms of this erosion issue in year one. We've had many growers on panels talking about their adoption of soil health practices, and they've pointed that out, that they went into it thinking this is going to be a long-term process. And then that fall or that spring, there were some really heavy rainfall events, and they saw their neighbors sold going into the ditches, and theirs was not. And they realized it was a benefit right away. And then beyond that, we have stream bank protection, restoration of stream banks, farmers thinking more about buffers between their farm and the ditches that eventually flow into our waterways. So this gets beyond the farm and really expanding to our whole urban and rural systems. I mean, pretty much urban or rural, a lot more has to be considered about how we manage this excessive water coming down on us in terms of stormwater control. And of course, the Water Conservation District's been very involved in this sort of effort. There's the seasonal differences in temperatures. There's also seasonal patterns in rainfall. And Elizabeth showed some historical data for what's been going on. This is based on some projected future expectations in terms of rainfall patterns in the different seasons. And I just want to point out a couple of things here. First of all, you can see fall and spring. Basically here, I'll first define the shading. So if you're seeing very yellow or very light blue shading, means very little difference in rainfall. And the darker the blue, the more increase in precipitation during that season. And so first of all, we see that in the summer, when we're likely to get longer frost-free period, more potential evapotranspiration, more water demand by plants, we're seeing little change in rainfall. And so for that leads us to an issue of increased frequency of summer water deficits in the future based on this future projection. What we end up with these wetter winters, falls, and springs is problems with field access, like I also already mentioned with spring. But in the fall, some special problems. For example, grape growers have been dealing with an increased problem with grape bunch rot. And for me, this has been interesting in that, for some years we were talking with grape growers, especially the Vitis vinifera wine grape growers. These premium wine grape types are not really well adapted to the Northeast cold winters. And since their planting of those has been expanding because of the market opportunity, they've benefited in terms of our growing seasons getting a little longer in terms of temperature, et cetera. But for some of these apple growers now, what they're seeing is, oh, wow, the longer frost-free period, their grapes are looking fantastic. They're wine grapes that in the past maybe wouldn't ripen fully. They're getting fully ripe, but then in the fall, wham, heavy rains and complete loss, or very close to complete loss of some of their crops due to fall rainfall. So it's not just temperature, but hydrology is playing a major role in terms of how we're seeing climate change play out in our area. So while we don't face the kind of mega droughts that are leading to major forest fires, drying up lakes and reservoirs dramatically in the Western US, and none of the models are really projecting that for our area. As I mentioned, some of the latest modeling is projected that in the future, plant water requirements are likely to increase during our summers due to a longer frost-free period and the warmer temperatures. But summer rainfall is not likely to compensate significantly for this, leading to this increased demand, leading to the risk of short-term summer water deficits increasing, and therefore more summer drought, more need for farmers who are growing high-value crops to think about irrigation, et cetera. In 2016, we had an example of a fairly rare event, a record-breaking drought. Those of you who were around in the state that year, especially if you were in Western New York, know it was pretty devastating economically for many farmers. A postdoc I had at the time, Shannon Sweet, did a major grower survey of the experience farmers had in that 2016 drought. Many of them feeling they really felt they had to adapt to this. This was a teaching moment, not that we expect that we're projecting, in the near future, every summer is going to be like this, but that this will become less rare in the future. And our survey did show that farmers are planning to do things differently based on that one experience. This slide was really based on a talk I gave focused on water supply and water issues. So I kind of emphasized in this first version of the slide here, that this farmers, significant number of farmers talked about having to develop better water sources, drilling more wells, investing in new irrigation equipment, better irrigation scheduling. But as someone who's been very involved in the New York Soil Health Program, I was surprised at how farmers really recognized that increasing soil organic matter was not a small factor in how they feel they could deal with drought in the future. The better water holding capacity of high soil organic matter soils was something they really looked at as significant. And so that brings me to my soil health slide, which some of you may have seen me talk about before under other auspices. But so this to me is like a real example of a great win-win thing. This is something farmers would be interested in doing, whether there was climate change on the horizon or not. Simply building resilience to weather variability, as Elizabeth talked about, increasing resilience not only to drought, but even flooding, because high organic matter soils often have a soil structure that allows better drainage as well. But on the other hand, it's also part of the mitigation strategy and something in terms of carbon sequestration. That organic matter that we put in the soils is usually often close to 60% carbon. That's carbon that's now in the soil that otherwise would be in the air as CO2. And its permanence does depend on, of course, farming practices down the road, but it's nothing in the overall net effect of what farmers could do about climate change. So it's part of farmers doing what's good for their own bottom line, reducing tillage, using cover crops, directly adding manures and composts are the strategies. I think is something very familiar to many of you. For farmers, the challenge is, thinking about adapting to climate change, there's still much year-to-year variability that's never going to go away. And so, discerning, is this a real signal of climate change that's going to be here to stay, something I really need to invest in, maybe a new drainage erosion control system, a new irrigation system, making that kind of capital. It's, none of the adaptation strategies for farmers are without risk or cost. So they can be a little bit paralyzed because of this. And this is, I think, where people with ag service providers, such as our conservation district people and our CS and then university climate scientists can help farmers discern which of the unusual weather patterns they're seeing do seem to be that the scientists have some confirmation that this is likely to be, this is part of climate change and something that's worth investing in for adaptation. And another thing with, the change in more dynamic and more severe disease weed insect pressure, we don't want farmers just taking the knee-jerk approach of, using more herbicides and insecticides, but using our IPM scouting really has to be step up a notch, I think, working more with farmers on developing non-chemical control strategies, keeping that up to date with what farmers are facing in the field. This is just one example. Cornell has its climatesmartfarming.org website, which has tools for farmers. Here it just shows one page of it. Some stuff that's focused on climate change, but others just looking at dealing with short-term summer water deficits, looking at this problem of frost damage on grapes and apples, etc. And so these kinds of things are popping up all over. The USDA Hub has some of these things. And so there is a lot, in the positive sense, a lot of things that beyond the farm, people are working on to help farmers cope with this climate change. It's a really exciting era. If I was a new, just coming into grad school now, I'd be very excited about some of the amazing new satellite data farmers can use. Many farmers are going towards drones that have large acreage to track what's happening on their farm, using year-to-year data analytics of what has happened on their farm to strategize about where they might be thinking about planting different crops, which zones of their farm they might use for different crops, and et cetera, which are more vulnerable to some of climate change. The upper left-hand corner is a new type of sensor. My colleague Alan Laxa, who also was retired a few years before me, developed for documenting or monitoring water stress in grapes. Just so much exciting stuff happening actually with new tools for farmers, new sensors, et cetera. So there's a lot that farmers can go to, and there's a lot of agribusiness and various ag service providers providing some of this information to farmers, consultants as well. Just my last couple slides are just reiterating what's already been mentioned on the mitigation front. So I think I can go through these last few very quickly because they've already been mentioned. But first of all, farmers, like all of us, I think, anything that's and improving energy efficiency or moving towards renewables has the potential, based on the details of how the economics work out, to be, improve their profit margin, improve their economic well-being. And so farmers are all about renewable energy. I don't know any farmer who's, is concerned about this in any negative way, but it does have to work out for them economically. But there's a lot of exciting things about happening here, a lot of expansion of this. I've been working in the Midwest with corn farmers in Iowa, and boy, the turbines are, every cornfield is filled with wind turbines. So there's just a lot of interesting things. Coming back to the nitrogen story has been, emphasized by the previous speakers somewhat. I wanted to mention one little aspect of that. First of all, there's a difference between whether you're using synthetic nitrogen fertilizers versus organic sources of nitrogen fertilizer and nitrous oxide emissions. Both, whether they're organic sources such as manures or legume crops in rotation, about 1% of the nitrogen going into the soil as it breaks down in the soil is likely to be emitted as nitrous oxide, the very potent greenhouse gas. So whether using organic sources or not, being more efficient with your nitrogen use efficiency is important. But if you're using synthetic nitrogen fertilizers, they're very energy intensive to produce. So your carbon footprint goes up just going and purchasing the nitrogen fertilizers. So that's the big difference. So part of the carbon footprint of using nitrogen fertilizers is separate from the nitrous oxide emissions part, but also the energy embedded in the manufacture and transport of synthetic nitrogen fertilizers. So that's the advantage of organic sources of nitrogen. I've talked to some organic farmers who think, there's no nitrous oxide emissions because they're organic, and that's not exactly the case. But if they are using organic sources, they don't have that carbon footprint associated with the purchase of nitrogen fertilizers. Manure management, I think this has been covered quite well by the previous speakers. First of all, there's just three, in terms of what I've brought up here, improving the manure management, better timing of our manure applications to farms in the spring based on our knowledge that now spring rainfall events are more intense and more frequent, using better rainfall forecasts before applying manures to dairy farms to reduce that nutrient runoff into waterways, and then also replumbing farms to reduce that, reducing methane emissions by either capturing and getting energy out of the manure or avoiding mixing wet and dry manures, etc. All of this, when I look at this cow pie, I see plenty of nitrogen, carbon, and energy. And so it's not a bad thing. It's a matter of managing that well for all of us. Finally, agroforestry and forestry have been mentioned a couple times. In the New York, I believe it's well over 80% of forest land in New York State is privately owned, and a lot of that is woodlands by farmers. And so I think farmers should be made more aware of that, and realizing that this is not only wildlife habitat, it's good for soil and water conservation, minimizing runoff and all those good things. Recreation, I'm out here with my dog Luna, where we take a walk almost every day. But there's also a lot of carbon stored in that above and below ground biomass. And so there's a reason to maintain the forests that are there or consider agroforestry on the farm. So Elizabeth talked about hope. And so, yeah, I'll just, my little words of hope are here. New York farmers, along with saltwater conservation districts, NRCS, Cooperative Extension, other technical advisors are already adapted to climate change. So we're already doing lots of good things, and there's more coming out. And continued access to strategic information, equity of access to farmers of all types, farmers with different levels of capital available to them for making adaptation decisions, and support of various kinds, including the wonderful incentive programs that come through New York State Ag and Markets and through the federal government, through NRCS. I think we can meet, the future challenge in our region, while also playing a role in mitigating the broad impacts of climate change on the environment. So I'll leave you with that. I think my timing is pretty good there. Aaron, I'll stop sharing.